Okay, here's your projectile motion practice problems that will help you prepare for the test on Friday. There are also 5 multiple choice, so you need to think about the concepts that we tried to teach you with projectile motion. All right, the first problem says that you have a stone. You don't know that velocity, and you know that it leaves at 45-degree angle. And it's going to move from here to here, dx, and dx is 50 meters. Now I'll make that 50 like that so I can have plenty of sig digs. And they want to know this value and then the time. So assume it's thrown on earth and it's thrown across level ground. Okay, so it's going to do something like this right here. It's going to return back to the same level that it moved from. So I said, well, I know that dx equals vxt. And I know that Vx would be the cosine of 45 degrees times V. And that's also Vyi because I have a 45, 45, 90 triangle. So my vertical and my horizontal speeds are going to be the same. Oops, let me fix that. And I think we called this Vx right here. And we didn't use Vyi, we just used plain old Vi. There's my Vx. So when I do that, the cosine of 45 is 0.7071 times V, and that's also my Vi. So I said, well, 50 meters is equal to 0.7071 V times T. So my time is going to be, in terms of V, 50 meters. And let's make that 50.0 meters over 0.7071 V. So when I divided that, I got an expression for my time to be 70.71 over V. Okay, I'm not going to worry about units right here because I've got to mess with the algebra to see if I can figure out the units and get them all good. So that's my total time. That means my time up is 70.71 over 2V, half of that, or I could call that 35.35 over V. So then I said Vy final equals Vy initial plus AT. My Vy final at the highest point is 0. Vy initial we said was 0.7071 V. Acceleration is going to be negative 9.8 meters per second squared because I'm talking about it rising. And then my T is going to be 35.35 over V. So notice I have a B here and a B here. So when I bring this over to this side, I get negative 0.7071 V equals, well, negative 9.8 times 35.35. I think when I did that, I got negative 346.5. And that was over V. So bring this V over to that side. So now I get rid of those negative signs. So 0.7071 V squared is equal to 346.5. So I divide both sides by 0.7071. Take the square root of that division, and I think that was the square root of 490. And when I did that, I got 22.14. So that was my speed, and then they wanted the total time. And this should have been time up. I apologize. So total time was 70.71 over 22.14. And when I got that division to complete, I got 3.2 seconds. So there's the first one. And yeah, you could see something like that. That's just algebra. That's not a big deal. All right, the second one. The second one says we have a football that's thrown at an angle of 45 degrees. Initial speed is 9 meters per second. It's not on Earth, so I don't know what the gravity is. But I can Vx by doing the cosine of 45 times 9 meters per second. And Vi is going to be the same because I have a 45, 40, 90 again. So this is going to be the sine of 45 degrees times 9 meters per second. So when I multiply those, I got 6.36. And both of them would be 6.36 meters per second because it's a 45, 45, 90. And then I said, well, the time is going to be Vf minus Vi over A, and that'll just be the time up. But the problem is I don't know A, so that was not a good choice. But what I do know is that dx equals vxt, and dx was given to us as 30 meters. I'm going to add some decimals here so I know I have some sig digs. Divided by 6.36 meters per second would give me the total time. And when I did that, I got the total time to be 4.72 seconds. So that means that the time up is half of that, 2.36 seconds. So now I can say, well, 2.36 seconds is equal to 0 minus my VI was 6.36 over my A. My A was what I was looking for. So when I solved that, I got my A to be a negative 2.7. So I'm going to say plus or minus because it depends on whether I'm talking up or down. Meters per second squared. So there's my acceleration on my planet. And I think that's, oh, they wanted to know how long is the football in the air. Well, we already got that right there. All right, third one. Third one says matters not kicked a rock horizontally off a cliff 35 meters high. So this is my 35 meters. Now it goes off horizontally, so don't introduce an angle there because that'll just make it really, really hard. And it does something like that and hits the ground. And from here to here, they tell us that dx is 80 meters. And they want to know all kinds of stuff. How long is the rock in the air? Well, we have d equals 1/2 at squared plus vit. It has no initial vertical velocity, so I can ignore that. So t is going to be the square root of 2d over a. Well, that's the square root of 2 times 35 meters. And a is 9.8. And I'm talking about it falling down, so I'm going to use a positive 9.8, because if I do the downward, then I can say that this, yeah, that works. Okay. So when I take the square root of 70 divided by 9.8, I got 2.67 seconds. And then B said, what is Vx? Well, Vx is equal to dx over t. Dx was 80 meters. T was 2.67 seconds. So when I took 80 and divided it by 2.67, I got my Vx to be 30 meters per second. And then my C was Vf equals Vi plus At. So Vf was going to be, that's 0, so it's 9.8 meters per second squared times 2.67 seconds. So when I did that, I got 26.2. But that's not what they wanted. They wanted this velocity here, so I have to do Pythagorean theorem, of course. So Vx was 30. Vf was 26.2. I was looking for this right here and this right there. So I said, well, V is going to be the square root of 30 meters per second squared plus 2.62 or 26.2 meters per second squared. So I did that math, and when I did that math, I got 39.8 meters per second. And now I need to angle with the ground. So I said, well, a tangent of theta is equal to 26.2 over 30. And I got theta to be, I think, 41 degrees with the ground. Alright, so that takes us through number 3. We'll do 4 and then we'll make a new recording. Alright, 4 said, Gene Zahn hurls a bad burrito off a cliff that is 5.2 meters high. The burrito leaves the cliff at an angle of 40 degrees, 18 meters per second. So this is very much like that third example I showed you the first day we did, or the second day actually, we did projectile motion. So it's going to do something like that. Alright, so part A says, how long does the burrito rise? Well, I got to do something about getting my Vx and my Vi. So Vx is going to be the cosine of 40 times 18. And notice the cosine of 40 times 18, when I did that, I got 13.8 meters per second. and that will never change. VI on the vertical, though, will be the sine of 40 times 18 meters per second, and it will always be changing because of gravity. So that was, when I multiplied those two together, I got 11.6. So this is the one that I'm going to use to help me find the time. Notice that I did this and I will never use that again. So VF equals VI plus AT. Well, when it gets to the highest point, VF is 0. VI is 11.6. A on the way up is negative 9.8. And T was what I was looking for. So I found the time up when I did that to be 1.18 seconds. Okay, so then the next part says, how high does it rise above the release point? So I want D. Well, D is 1/2 AT squared plus VIT. So that's 1/2. A is 9.8. We're talking about it rising, so I'm going to make that be a negative. Don't forget to square your T. VI was 11.6. T again was 1.18. So multiplied that times that. Then I squared my T and did it times a negative 1/2 of negative 9.8. And when I did that, I got 6.86 meters. Right, then C said, how long does a burrito fall? Well, I have to figure out about the falling. Well, the distance that it falls has to be the 6.86 meters that it rose, plus the 5.2 meters above the ground. So that's 12.06 meters that it has to fall. So I did that same exact equation. That's nothing I want because I'm talking about it falling and VI is 0. So I said 12.06 meters equals 1/2. Now it's falling, so it's a positive 9.8. T squared. So T is going to be, when I did it, I got 1.57 seconds that it had to fall for. Alright, then part D, as in dog, said, how far does it fall? Well, we already figured that out. 12.06 meters. E. So what is Vx? Well, Vx never changes. So whatever Vx was from the get-go is what Vx is going to be. So I got to go back up there and look at that. So see if we can get it back. Oh, come on, technology, give it back to me. So I'm going to go down here and see where my page is. Hate when that happens. Let me pause it for a minute. Alright, well, I lost that page, so I got to go back and calculate Vx now, and it's the cosine of my 40 degrees times my 18 meters per second. Sorry about that. And that gave me my 13.8. And that was the answer to E. And then F said, what is the speed for the vertical when it reaches the ground? So VF squared equals VI squared plus 2AD. Well, VI is 0 because I'm looking at it falling from the very top. So that's 2 times 9.8. And it's going to fall 12.06 meters. So when I did that math, I got VF to be, let me move and see what that is. VF to be 15.4. And I'm going to run out of time, so I'm going to go quick. Vx is 13.8. VF is 15.4. And they wanted to know this right here. So I did Pythagorean theorem, which I'm not going to show you because I'm afraid I'm going to run out of time. And when I did that, I got, it looks like 26.68. 26.68. And then I found this theta, because that would be the theta with the ground. And I said the tan theta is equal to 15.4 over 13.8. And my angle with the ground I found to be 48.14 degrees. I'm going to save this one and then we'll do the last one.